it's Gabrielle, and this video is a sample from Studyclix Boost, our new rapid revision tool. Go to studyclix.ie/boost to find out more.
Hi folks, so here we're looking at beginning our study of looking at complex numbers. And don't panic, you hear the word complex, it does not automatically mean complicated. So let's start off here with solving an equation that we should be familiar with. X squared minus 9 is equal to 0. So when we're solving this, we generally bring the numbers to one side, letters to the other. And when we have x squared is equal to 9, to work out x, you just take the square root of 9. And then what two numbers multiply together make up 9? It's plus 3 and minus 3. Not a bother. Number 2. Now, applying that same approach to this equation. So it's still a quadratic, it's a U-shaped function. So when I bring my number across, I get x squared is equal to minus 9. Now, to find out x, I take the square root of both sides, and I cannot get the square root of minus 9. Even if I put it in my calculator, I'll get math error. So they invented these things known as complex numbers to eradicate that difficulty. And what they do is they split up that square root of minus 9 into the square root of 9 times the square root of minus 1. Now the square root of 9 we worked out previously to be plus and minus 3. And then the square root of minus 1, they invented this complex number and gave it the symbol I. So I is the square root of minus 1. So your answer there is plus or minus 3i. So if we look at question number 3, x squared plus 25 is equal to 0. Bring across your plus 25, change its sign. Now take the square root of both sides. And the same issue as in part 2 will arise here. So what you do is split up that square root of minus 25 into square root of 25 times the square root of minus 1. Square root of 25 is plus or minus 5. And the square root of minus 1 is this new number, this complex number known as I. And then the last one here, same procedure, bring your 13 across, becomes a minus. Take the square root of both sides, get rid of that minus under the square root by bringing out your square root of minus 1. Now there's no nice square root of 13, so I would just leave it in the third form and put in your wee I there at the end for your square root of minus 1. Moving on from that, we'll look at this thing dealing with powers of I. And this will become very important when you start looking at multiplying complex numbers. So, as we mentioned there in the previous part, I is the square root of minus 1. So if I had I squared, which is part 1, I squared, like x squared is x by x, I squared is I times I. Now I know that I is the square root of minus 1 times the square root of minus 1. And if I was to work that out, the square root of minus 1 times the square root of minus 1, I just get rid of the square root and it leaves me with minus 1. So I squared is equal to minus 1. For part 2, just using my rules of indices here, I cubed. So I cubed is the same as I squared times I, or I to the power of 1, because we add the powers. Now I squared we worked out in the previous part there to be minus 1. I is just I, so I cubed is minus I to the power of 4. Now you can either go I cubed by I to the power of 1 or I squared times I squared. Both will give us the same answer. Now I squared we worked out there in part 1 to be minus 1 times minus 1, which gives us 1. I to the power of 5 here, which is made up of, using my rules of indices, I to the power of 4 times I to the power of 1, or I to the power of 3 times I to the power of 2, gives us the same answer. I to the power of 4 is 1 times I, which just gives us I. I to the power of 6, I to the 4 times I squared, I to the power of 4, we worked out there to be 1, I squared times minus 1 gives us minus 1. So I to the power of 6 is minus 1. I to the power of 7, and we should hopefully see a pattern emerging here now. Is I to the power of 5 times I squared, or I to the power of 4 times I cubed. I to the power of 5 worked out there to be I squared worked out to be minus 1. which gives me minus 1a or minus a. And what we start seeing here is the colours, say the yellow, red. If I wanted to work out a to the power of 8, I guarantee it'd be purple. Every section of 4 repeats itself. So if I had a to the power of 8, just do a wee one here on the side. That's the same as a to the power of 5 times a to the power of 3. A to the power of 5 is a. A to the power of 3 is minus a. Times them two together, get minus a squared. And a squared is minus 1. So minus 1 gives me 1. Exactly as I can see there in the purple. So every section of 4 repeats itself. So every multiple of 4 is going to give you 1. So if I had a to the power of 8, gives me 1. A to the power of 12 gives me 1. A to the power of 16 gives me 1. Then they've asked me for a to the power of 17. So a to the power of 17. Get your multiple of 4. How many sections are there? So it's a to the power of 16 times a to the power of 1. A to the power of 16 is the same as a to the power of 4, which is 1, times a, which is a. A to the power of 22. Again, get your closest multiple of 4 that goes into it. So that's the same as a to the power of 20 times a squared. A to the power of 20 is the same as a to the power of 4, which is 1. A squared is minus 1. And that gives us minus 1. So when you're given them powers of a's, try and work out how many times does 4 go into it evenly. And then whatever's left over, you can figure it out from your first 4.